Welcome back, my friends. It's time for another video. This is the IM3 final review part 2. And the first thing we're going to do is we're going to talk about how to convert from radians to degrees. And in order to convert from radians to degrees, you multiply by 180 over pi, 180 degrees, because that's what's going to cancel that pi. This pi is going to cancel with this. And you're only left with degrees, no more pi's. These can both be divided by 18, and that'll leave you with 10 degrees here. And so we have negative 71 times 10, so that's just negative 710 degrees. The other ones are very similar. It's just a matter of simplifying the fraction. We have other things to get to, so I'm going to move on. So this one here, we have to expand completely. And we have to know the row of Pascal's triangle. So this one is 1, 5, 10, 10, 5, 1. So I recommend that you write those out and leave yourself a little bit of space so that it can fit. Maybe I gave myself too much. It's probably fine. And after you've done that, you're supposed to write in the variables. I'm actually going to try to color. I'm going to use different colors slightly because it just helps it to stand out more. And here we go with the 3. So this is times 3. Give yourself a little bit of gap between the a and the number here so that the, maybe that's too much, but just to make sure that the exponent can fit in. So I'm just going to try to make sure that I have that. And then now we go with the exponents. So 5, 4, 3, 2, 1, 0, 5, 4, 3, 2, 1, 0. Make sure you get that order right. Now these are all pluses because it's a plus, so I just put pluses before each of the blue numbers. And that is the first part, and if you get that right, I know it's multiple choice, so there's no half credit. But if you were doing this out, I would give you half credit, but oh well. So then we simplify this, and we're going to get a to the 5th, because the 1 times doesn't matter, and 3 to the 0 doesn't matter, plus 5 times 3 is 15, and then we have a to the 4th, plus 3 squared is 9, so 10 times 9 is 90, 90a cubed, and then we have plus, this here is 27, 3 cubed is 27, times 10 is 270, a squared, plus 3 to the 4th is 81, times 5 is 405, plus 81. And that is the answer. And that is it. Number 31. I recommend that you pause the video and try to do these yourself. Try to do number 30. Try to do the other ones. And then we're going to move on here. So number 31. I'm going to do number 31, and so because this is cubed, it's going to be 1, 3, 3, 1. And we put those terms, 4x. Now, whenever there's a coefficient, I always use the parentheses. When it's not just a variable or just a constant, I always recommend using the parentheses, because otherwise you'll mess up on the exponent. And you're going to need those parentheses. And I have here times 1. Let me fix that here. It looks too much like a minus. Times 1 times 1 times 1. And again, the signs don't really matter. They're all pluses. So, and I probably should do the exponents before I do those, but oh well. Oh, I just wasted a bunch of time because they just wanted the x squared. My bad. And I got that right. I just did the same one like half an hour ago, and I nailed it, but for some reason I forgot on this one. So that means that this is the one that we're looking at right here. And that means that we have 3 times 4 squared, so 4 times 4, times x. And so this is 48x squared. And they just want the coefficient. They didn't want the whole 48x squared. So the real answer is 48. And that's it. 48. Let's try this one here. Coefficient of v. So we're going to have, so this is 4. So we're going to have 1, 4, 6, 4, 1. And you're going to have v to the 4th, v cubed, v squared, and then just the v. So v to the 1 is here. And that's going to be multiplied by 3. And what's its exponent? Well, the exponents always have to add up to this number right here. And so that means that this is 3. The sign is positive. And so we can just take this right here and simplify it. 27 times 4, that's 7 times 4 is 28 times 80, so that's 108. So this is, the answer is 108. It's because all they want is the coefficient. And that is that. Number 33. It's a good idea for you to think this through before listening to me. So try that, and here we go. It contains 1 apple, 1 peach, and 1 orange, okay? 1, 2, 3 items. You randomly pick a piece of fruit to eat. Okay, so you have 3 choices. Then you pick another piece of fruit to eat later, and then you have 2 choices. So the answer is simply 6. Because they're basically wondering, what are the possible outcomes? And if you want me to show you this, actually, no, I was misreading it. Yeah, so let's say you have A, B, and C. It's basically how many different ways can you pick, can you arrange 2 out of 3. So you could pick A first, then B. You could pick A first, then C. You can pick B first, then A. You can pick B first, and then C. You can pick C first, and then A. You can pick C first, and then B. So those are the 6 possible outcomes, so the answer is 6. I don't know why I said it wasn't. It is. I had it right the first time. So there's 6 outcomes. Yay. Because in this case, the order mattered. So you can do like a permutation formula. And we'll get to that when I go down here, when I do the permutation. I'll give you the formula. I just wanted to show you how that works. Okay, a spinner can land on either red, blue, green, or yellow. That's 4. The spinner has 4 possibilities. You flip a coin and then you spin the spinner. Flipping the coin has 2 possibilities. So the answer is going to be 8. If you think of tails, heads, right, and then you have red, blue, green, and yellow, you're picking one of these two, and then one of these four. So you have 2 options and 4 options. So 2 times 4 is 8. And I could spell this out a little bit for you. It's T then R, T then B, T then G, T then Y, or it could be H then R, H then B, H G, and H Y. So that's how you get the 8, and that's the answer, and we are ready to move on. This is the answer right here, 8. Okay. State if each scenario involves permutation or combination, then find the number of possibilities. All right, so we need to talk a little bit about combination and permutation. So these things, you're probably wondering, like, hey, I don't remember this. Yeah, we did it for like one day in like February or something. Like, I don't blame you if you forgot about these. But here's how these work. Let me actually write this for you. Let me go over the basics of it. In a permutation, order matters. It uses words like ordered, or order, or arranged. Okay? Combination is where order doesn't matter. You're just picking. Combination is pick K out of N. Pick like 2 out of 3, 3 out of 5, 5 out of 8, whatever. Order doesn't matter. Whoop, doesn't matter. Okay. So, if this, and I'll actually write the word default. So if you don't know what it is, it's probably combination. That's always a good rule of thumb. Because the only way to do permutation, they actually have to say the words like ordered or arranged, or somehow communicate that the order things is very important. So let's look at number 35. And if you can, I would try it again on your own. So pause the video and try it, and we're back. A team of 8 basketball players needs to choose 3 players to refill the water cooler. Well, this is combination. And so the combination formula is n factorial over k factorial times n minus k factorial. And what do those numbers mean, and what do we get? Well, n is always just a good rule of thumb, just to help you remember which one's which. N is greater than k. So we have 3 and we have 8. So guess which one's which? N is going to be 8 and k is going to be 3. All right, so that's how we know which one's which. And then you plug it in. So you get 8 factorial over 3 factorial times 8 minus 3 factorial. And then we have to simplify. If you, again, at each point I recommend, once you get unstuck, pause it and try it yourself before you watch me do it. 8 factorial, what is factorial? Well, it just means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But I'm going to stop at 5 factorial. This is just a little foresight I've developed from doing a million of these, is if I can see what happens in the denominator, I can see, and I'll do this one out all the way, 3 times 2 times 1, just to show you something. 8 minus 3 is 5 factorial. And so the reason why I stopped at 5, I could have done 5 times 4 times 3 times 2 times 1, but I'd be wasting a lot of time, and, you know, it's not really worth it for me. So I stop at 5 factorial so I can cancel these. And here, 3 times 2 times 1, I actually don't usually write the times 1 because 1 doesn't matter in multiplication. So I usually you leave that off. 3 times 2 is 6. So those cancel. And we're left with 8 times 7. And so that is 56. And that is the answer. That is how many groups of 3 we can pick out of 8 players. And that's how you do a combination. Next up, number 36. There are 15 applicants for 2 jobs, computer programmer and software tester. Okay, so they're not the same. So if we're going to pick 2 out of 15, it's not like the 2 spots don't matter. It does matter which one's which. And that's what, even though they didn't use the words order and arrange, that's what tells me this is a permutation. And the permutation formula goes like this. N factorial over, n minus k factorial. And if that looks familiar, it is exactly like the combination formula, with the only difference being that there's no k factorial. And that's why sometimes I say combination with an exclamation mark. It helps me remember, oh yeah, it has that k factorial. Combination. I've been doing that for 20 years. All right, so there we go. So n is still greater than k. So that's still the same. And so that means that for us here, n is 15 and k is 2. The number 2, not also. All right, and now we can plug stuff in. So what do we get? Use a slightly different color. So this means that this is 15 factorial over 15 minus 3 factorial. Did I just say 3? I meant 2. How is that possible? Okay, so this simplifies to be 15 times 14, and if you do all these out, you are a darn fool. You would be a fool. Okay, so we're just going to stop at 13 because I can see that the denominator is 13. And maybe you want to do the denominator first. You know, maybe that way you see it, so you know where to stop. And then we have those, and these are going to cancel. And so there's no reason to do all that out. And this one right here is 210. So that's the answer. So this is a permutation. In fact, I'm going to label it. They did say I'm supposed to say what it is, so I have to follow the instructions. Permutation is that. And this one here, this is the combination formula. And that's how this one works. So let me zoom out just a bit so you can see them together. And that's numbers 35 and 36. That's how you do combinations and permutations. I hope that was helpful to you. If you like that, please like the video, share it with your friends, and subscribe. Also, buy my merch. Thank you, and have a good day.